I'm from Asia University, Taiwan. It's my great pleasure to chair this IPv6 readiness measurement board meeting. First of all, I'd like to welcome all of you to participate in this board meeting. As you may know, IPv6 readiness board is focused on IPv6 readiness measurement. And there are several different kinds of the readiness measurement. Each measurement can provide its own insight in some specific aspect. So the different measurement can lead to different outcome and different interpretation. So the board is aimed to provide a platform not only for sharing and exchanging the status, the information and the knowledge related to the IPv6 development, but also for building the consensus of common measurement criteria. So today we're very happy. We have invited 4 speakers from Australia, Japan, India, and Taiwan, who are going to introduce the recent development of IPv6 readiness measurement. First of all, so I'd like to ask the first speaker, Mr. Jeff Smith, to give his presentation. Please.
Hello everyone, my name's Jeff Schmidt. I work for Telstra. I'm a technology team manager and I manage a team of network engineers that build IP carriage for wireless for Telstra. So I'm giving you an update on where we are at with our V6 deployment in wireless. So our driver in wireless is actually driven by the pressure on private address space. So the addresses we allocate to wireless devices are in the private address space. And we have found that with always-on connectivity in wireless, plus the need to connect to other parts of Telstra for streaming services or other shared services, has put a lot of pressure on the private address space. And we don't have pods like some large carriers that can reuse that private address space. We have a national deployment which shares the one routing domain. So it's very difficult for us now to split that up into pods. So we're working hard to deploy a single stack V6 solution to take the pressure off that private address space. So this is a high-level architecture of our network. So the EPG is the Evolved Packet Gateway, which is similar to a BRAS, where subscriber terminations or PPP or PDP sessions terminate and the addresses are allocated. In front of that is the CGNAT platform, which does the carrier-grade NAT function and translates private address space to public address space before it's advertised into the internet. So our experience. At this point we have deployed a dual stack deployment for the iPad, and that has been reasonably successful, or quite successful actually, and we are now seeing quite a number of devices being allocated V6 addresses. And the way we manage these deployments is we ask Apple to provide us with a certain build for the devices as we sell them through our Telstra shops. And when so as they're introduced into the network, they automatically or from the subscriber's perspective anyway, or the user's perspective, their device starts using dual stack in this case, and it's transparent to them. We're planning to deploy a single stack later this year. We still have some work to do. At the moment we haven't got DNS 6.4 running, so in doing that limits some of the traffic that is generated from the V6 device. So as I said, we use DNS 6.4 as a migration step to go from dual stack to single stack. The devices will use V6 in preference, and what DNS 6.4 does is it will introduce a V4 destination into a V6 address, and the V6 will offer a V6 address to the device for all the V4 destinations, and will be quite a step and increase in traffic as that occurs. But it's also been a useful way to migrate, as if we do have issues with subscribers, we can roll back the DNS. Tethered devices use a separate APN, so tethered devices are more of a challenge to run over a single stack solution because of the number of protocols and applications and the implementation of those specific protocols on tethered devices. It is more likely that we will impact customers' traffic. So tethered devices will be treated separately and be implemented later. We have done quite a bit of work to ensure that all the internal services are V6 enabled, or as well as that, we have also some 6.4 deployments back into our internal infrastructure for services that are hosted internally. 464 XLAT is a capability that runs on Android today, and what it does is it will translate a V4 only application into V6 on the device. So that allows us to run single stack. 464 XLAT was seen to be quite important a few years ago. Applications, particularly Skype, didn't support V6, so it was seen to be quite important. But over the last couple of years, with Apple mandating native V6 for their applications, we're finding that a lot more applications are supporting V6 natively on the wireless devices. Corporate VPNs are still a challenge for us. We use test APNs to ensure that all our services on the production network are reachable and accessible. In saying that, though, it's still very difficult to test all the applications that customers access from the internet. So testing is still fairly challenging for a V6 deployment for mobile subscribers accessing the internet. So this slide shows a step increase in V6 usage as we rolled out dual stack to the iPad devices. It's not shown on that slide, but the number of users or devices that are using V6 addresses is in the hundreds of thousands. This slide shows a step increase in V6 usage for a separate APN, which is specific for voice over LTE or VoLTE. The VoLTE service that we've deployed is single stack V6, and it was significantly easier to deploy because of the closed community or the connectivity within a VoLTE service. So it was fairly easy to deploy. And that step increase there is where the iPhone build delivered to Telstra was enabled with default with voice over LTE. And again, that was a migration step for us to step up usage on the network by controlling the device and how it's built and supplied to Telstra. The number of devices using V6 for VoLTE is now in the millions. This slide describes some mail services we were having, but in fact what that turned out to be was the reachability of the global V6 address on different Cisco platforms. We found that the Cisco iOS platform behaved differently to get to a global V6 address, which was one hop away compared to a Nexus platform. So there is still some learnings to deploying V6. What we are finding though, that bugs relating to V6 is becoming less common as the industry continues to deploy more V6. So our APNs, which are used for, as I mentioned, voice for VoLTE or internet services, can control how we, whether we offer a V4 only address, a dual stack address, or V6. There is control in the network and also the way the devices are configured to control which devices and how much connectivity is V6 on our network. We found that some devices, for example, a wholesale solution, we expected it to use a specific APN, and we found that a particular device wasn't using that APN and wouldn't in fact allow us to use a different APN for that wholesale service. So we had some challenges where we had to go back to that solution and upgrade the HLR HSS to allow single stack and dual stack devices to connect. So as I mentioned, testing is very important in being able to deploy V6 service, particularly an access network connecting to the internet. So migration strategy is by device by device to migrate to a V6 solution. Testing, as I mentioned, internal trials to get a user community testing the services is also important. Dual stack on a single device, as I mentioned, turning on DNS 6.4 will increase the amount of usage of V6 on the network. Then single stack on a less common device, so it's probably an Android device that is not particularly popular, I suppose, to ensure that if there are issues, they're limited to a specific device. And as I mentioned, tethering is probably last. So as we've gone through these deployments, we found it important to engage community through user groups, forums like Whirlpool and others to update our customers on what's happening so they are less frustrated with issues as they occur. We have some flexibility to allow engineering to speak to customers if necessary. And it's also important to keep management engaged and updated on the progress as well. So that's it.
Any questions? I have one question. As you mentioned before, you have some data about the device availability. So, could you briefly describe what kind of the device are being involved in the survey?
Sorry.
The device availability. You have some
Device.
figure. Okay. The page. You know, the more device built. What kind of the device?
So that's the Apple device, the iPhone device. So that in fact, all the devices on our network using VoLTE, voice over LTE, are using single stack. And it was because it's a sort of closed community of interest within that solution, it was easy to ensure that all those devices involved in that connectivity were V6 enabled. Compared to the internet, where you have to get access, you're getting access to so many endpoints on the internet, a lot of which is still V4. So with the VoLTE solution, we enabled V6 on all device types. Yeah, and the step increase there was as the device delivered to us was VoLTE enabled by default. So previously, before that step increase, VoLTE had to be enabled on the phone to use V6.
Owen DeLon, Aaron AC, but speaking for myself. You mentioned needing a customized iOS build to turn on V6. I'm confused by that.
It wasn't to turn it on. It was the reachability we found was that with an iOS device, when you pinged the global V6 address, which was a hop away, it replied with the link local address, which wasn't expected, and we had to adjust.
This was on the iPhones and iPads?
No, this is internal infrastructure.
Yeah, no, I was talking about, you said you needed a custom build from Apple.
The custom build, that's a separate point. That the issue with iOS and pinging
Yeah, I wasn't talking about that, but
okay.
earlier than that,
Yeah.
you had said something about getting a custom iOS from Apple for the devices you're selling in order to enable V6 on iPads and iPhones. And I was a little confused as to why that is. I don't think the other carriers are doing that.
It's not really custom, it's really a carrier build. So each, or certainly Telstra, we describe to Apple how we want the device built. And they build them for us, and then we sell them so that they're a Telstra build.
Okay.
And in that, we tell them whether they would set VoLTE to be default enabled, for example.
Okay, because I know, for example, I can walk into virtually any carrier in the U.S. with an unlocked iPhone, and it just works.
For that device,
it works again.
You wouldn't have control on that device to use either single stack or dual stack, for example.
They usually do that with APNs.
Yeah, but I guess that control you don't have on the device per APN. So Telstra would go back to Apple and say, on a per APN basis, this APN will be dual stacked, next APN will be single stack, for example. So we describe to Apple how we want the devices configured for us.
Any other question? Thank you very much, Jeff. Thank you for your presentation. There's some souvenir provided by Tidemnik to express our appreciation. Thank you. Thank you, Jeff. Thank you. Let's move to the second speech. The second speaker is Mr. Kiraki Kawabata-san from Japanik. He's going to talk about the IPv6 readiness measurement in Japan. Please.
Thank you. Hi everyone, my name is Hiroki Kawabata from Japan Network Information Center. We call it JPNIC for short. Same as PNIC, we distribute IP address and ACE numbers as National Internet Registry in the Asia Pacific region. Thank you for inviting us this time. I'm glad to have this opportunity to share with you. I'm going to talk to you about IPv6 deployment status and activities in Japan for about 50 minutes. Let's go talk now. As you know, there are many players that provide various services on the internet. This slide shows a rough classification of these players. About some players who we show in this figure, I'd like to introduce the status of IPv6 deployment in Japan. This slide shows a summary of each player in the point of IPv6 deployment status in Japan. You can see that there are various among players. IPv6 deployment in contents and application providers is not yet advanced. It's recognized as a player who needs further action in the future. Among data centers, clouds, and hosting companies, major companies are supporting IPv6, but other companies are not supporting IPv6, and they are going to improve their network and equipment in the future. In contrast to these players, the players who provide connectivity to end users and company users are more supporting IPv6. Many of Japan's major ISPs provide IPv6 connectivity using PPPoE, a so-called tunnel IPv6 connection, or IPoE, the so-called native IPv6 connection. In Japan, FTTH is more popular than ADSL to access internet for end user. Now, 40% of FTTH users are using IPv6 connection. Among CATV internet providers, several companies are working on supporting IPv6, but free IPv6 support is not advanced. It seems that they need to go forward in the future. About the mobile network players, they started to support IPv6 rapidly from late 2016 and 2017. After the next slide, I'll explain more details about some players. This map is the result of survey by Google. It shows the adoption rate of IPv6 in the Asia Pacific region. In this map, the country where is painted the more deep green color has more wide adoption of IPv6. It is reported that adoption rate of IPv6 in Japan is about 23% at this time. I'll move on to the next slide, and I'd like to share the situation about FTTH. Nippon Telegraph and Telephone Corporation, the largest telephone company in Japan, we are called NTT for short. NTT has built a very large network called FLETS. As of 2017, subscribers are about 20 million. They called the FTTH service provided using this network as FLETS Hikari. FLETS Hikari is a collective name for various FTTH service menus. They began operating the current network in 2008. IPv6 has already assigned in this network. Since 2011, they have started IPv6 internet connection service. The blue bar graph is the slide, in this slide is the subscribers using IPv6. And the orange line graph is the ratio of IPv6 penetration in phrase service. Since 2011, the number of service users has not increased so much. In 2015, the trend has changed. According to the latest data, it is reported about 40% of subscribers are using IPv6 connections. This slide shows the proportion of IPv6 users to the total subscribers in phrase service. The gray bar graph is the total subscribers, and the blue bar graph is the number of the subscriber using IPv6 connection service. The orange line graph is the ratio of IPv6 penetration. Compare the gray bar graph with the orange line graph. It shows the trend of new subscribers in different from the trend of usage of IPv6 connection service. And from this graph, it shows that IP adoption rate of existing users is increasing. FTTH service is also provided by several companies other than NTT. This slide is the example of some of FTTH service. The blue line graph is this adoption rate of KDDI. The big telecommunication company has a nationwide network infrastructure and has provided FTTH service. We call it AU Hikari. They said that it is 100% compatible with IPv6, and end users can use IPv6 immediately without application. The orange line chart is the ratio of Tube Telecommunications. Tube Telecommunications are one of the KDDI's group company, and they are not a nationwide ISP. And their service area is only Central Japan, is actively working on IPv6 adoption, and they are going to free support with IPv6 shortly. I will move on to the next slide. After 2015, the situation of mobile network player has changed drastically. There are three major mobile carriers in Japan: NTT Docomo, KDDI, and SoftBank. NTT Docomo is the NTT group company, and I introduced NTT as the previous slide. And KDDI provide a mobile service as AU. People is well known as AU than KDDI. These three mobile carrier has beyond IPv6 support since the end of 2016, and last year they are announcing that they are going to support IPv6 gradually when the network equipments will be replaced in the future. Their IPv6 supporting plan for subscriber is gradually too. Most of mobile subscribers in Japan are usually replaced to another smartphone every 2 years. First of all, they support only smartphones that has released as new model. After that year, they are going to increase the number of the IPv6 supported smartphone model and lead to increase the ratio of IPv6 adoption in the future. In Japan, there are many MVNO. MVNO is an abbreviation for mobile virtual network operators. They provide service using the network of these three mobile carriers. IPv6 support for MVNO and public wireless LAN service are not yet advanced, and it is a future challenges. The next slide is IPv6 adoption status of internet service providers. This table is a result of the survey by Google. It shows the IPv6 adoption rate of each ISP operators and the top 20 of the IPv6 traffic volume to Google. Google is measuring the amount of IPv6 traffic to various services provided by Google. In the table, some nationwide ISPs are listed. In addition to this, there are some operators who provide service only in specific areas and operator for academic and university. I'll move on to the next slide. Many ISP in Japan have already started providing IPv6 service, and users connect to the IPv6 internet by using the network provided by NTT called FLETS. There are two types of connecting to the IPv6 internet, native IPv6 connection and tunnel IPv6 connection. The ISP will choose one or both of these connection methods. In order to make a native IPv6 connection, the ISP need to contract and connect with VNE. VNE is an abbreviation for a virtual network enabler. Due to the NTT's technical specifications, 16 VNEs are the upper limit. Currently, VNE service are now provided by 7 companies, mainly major ISPs and IX operators. The next slide is the IPv6 support for data center and cloud and hosting service. There are some companies that proactively promote IPv6 adoption. IIJ and Sakura Internet, one of these companies has clearly declared providing IPv6 service. These images in this slide capture their presentation material. In addition to this, there are many business operators who are planning a gradual IPv6 adoption plan by addressing the timing of facility and equipment renewal. According to a survey by operators, customers seem to have little need for IPv6. Also, if an operator has enough of IPv4 address, they are not aggressive in adoption of IPv6. On the other hand, the related organization reported there are many data centers or cloud service operators trying to get IPv4 address by IPv4 address transfer. Okay, in this slide, we will introduce the IPv6 adoption status among the content and application service players. This table in this slide is summary of in the IPv6 compatibility status. These status are updated on the website every day, and we can always check them. The left side of the table lists the URLs of the website and supports IPv6 access. And the right side, lists the URLs of websites are not supported IPv6 access. Many websites that support IPv6 access. Many websites that support IPv6 access are web pages of ISPs. In addition to those, we can see the websites that provided by newspaper companies, credit card companies, and government and agencies. These websites are supposed to have many access. On the other hand, many websites that provide service on the internet, such as video streaming, e-commerce, and blog sites, do not seem to support IPv6 address. Okay. After this slide, you can show about engagement activities in Japan. At this time, I'll skip my explanation. If you have interested in this, would you check this session page? Sorry, it's all my presentation. Thank you.
Any question? I have one question. As you mentioned, in Japan, the public Wi-Fi services,
Yes.
that doesn't started to provide the IPv6 service, but in Taiwan it is different. So in Taiwan, relatively to provide the public Wi-Fi service to be IPv6 enabled is relatively easy compared to the other service. Could you briefly describe the reason why it's different in Japan?
Sorry, now I don't have information. Yeah. Okay. Yes.
Any other question? Thank you, Kazabata-san. Thank you very much.
Thank you very much.
I have a souvenir. Okay. Thank you. Let's move to the next presentation. The next speaker is Mr. Ajay Kumar from Mumbai Internet Exchange, India. He's going to introduce the current status of IPv6 readiness measurement development in India. Please, Ajay.
Thank you, sir. My name is Ajay Kumar, working with Mumbai Internet Exchange. I had worked with Nixie, and there we got the opportunity to work on promotion of IPv6. Our government is very enthusiastic and futuristic that we should have IPv6. So they have already planned that we should have the roadmap so that in future all stakeholders present in India should be providing services on IPv6. How to operate it? So as per the Cisco latest report, you see that we have already around 50% deployment. Around 70% the transit provider are on IPv6. In India, daily new users are going to add. Daily new ISPs are given the license by the government of India. So you see only 24% users who are using the internet are on IPv6. So Department of Telecommunication, Ministry of IT, Government of India was running a program for adoption of IPv6 in all networks in India. So in India, government was thinking and still have plan that without private partnership, it cannot be done any achievements. So our private operators are also shaking the hands with government. The one private operator, SIFI, has started working on IPv6 in 2005. Along with the government organization, ARNET India had taken a project along with Indian Institute of Kanpur to run the project on IPv6. Indian Registry for Internet Names and Number, the Indian NIR, is virtually giving IPv4 free. And the new telecom operator, Reliance Jio, the service from first day was on IPv6. If you see the 15 economies regarding the IPv6 deployment, I am happy to share that India is number one. And due to Reliance Jio, the new operator, other is Japan, Myanmar, South Korea, and other countries are doing their best to promote IPv6 and so that IPv6 should be deployed. NIXI, the first internet exchange in India, has taken a number of steps to encourage IPv6 in the country. NIXI has set up the parallel test bed to give the platform for testing the IPv6 to the connected networks. With help of APNIC, they have done series of awareness programs. After that, the NIXI made all equipments on the dual stack, so they can support both IPv4 and IPv6. The new internet exchange, Mumbai Internet Exchange, is also supporting IPv6. Our 50% peers are on IPv6. Our policy is that if we get any new peer, we give one IPv4 address and one IPv6 address. But sometimes, few peers are saying that we don't want IPv6 right now, we will take future. Our website, Mumbai IX website, is IPv6 enabled. And we are also planning to have IPv6 workshop in near future. In India, every new day, new ISPs are coming to work, new licenses are being issued. I personally feel that in India, training of IPv6 and BGP is very important and required. So we are discussing with international organization to have trainings on these required technologies. So in India, not only the government, so many organizations like ARNET, BSNL, everyone is doing their bit to promote IPv6. ARNET India has trained around 3,000 government staff along with support of Ministry of IT to train on IPv6. The Indian CCTLD, their DNS infrastructure is IPv6 ready. They can take the Quad 8 DNS records. Their registrar are supporting on IPv6. The entire infrastructure hosted on IPv6. The WHOIS service and all other services are on IPv6. So you see this cycle. So government started with first roadmap. They have made the task force, awareness workshop, empowerment of consultant, seminars, and posting of the government professional as a nodal officers, deployment of test bed, and then release of second roadmap. In 2012, our government Department of Telecom thought that we should have policy, national telecom policy, which should include IPv6, so that all stakeholders, all services can be provided on IPv6. So on that roadmap, they have considered who are all stakeholders, and they made the committees. Everyone knows that in the government, without committees, work cannot be done. But it all depends on the priorities, who is chairing which committee. The head of department, the secretary of that department was chairing that and taking the update, how India is progressing on IPv6. And in the other committees like steering committee, working committee, the other private operators was given the task to lead on the deployment. So as per the first roadmap, you see the timeline was given to each stakeholders. So service provider and content provider, equipment manufacturer, government organizations. So if any domain of CCTLD has been registered, so as per their directions, they should have the quad record or support IPv6. For any equipment which is going to be imported in India, so timeline was given that you should support IPv6. So government regularly reviewing it and deciding what is the status. After some time, government realized that work has not been done so far, so they revised the time frame. As per the new time frame, everything, every service which are going to be provided in India related to internet, that should be on IPv6 from 1st January 2017. So Government of India's one department has been given task for testing of IPv6 and certification. So our Government of India has many initiatives. Digital India, development in India, made in India. So if any equipment is being made in India, for that the TEC has been given the task to test that this equipment is IPv6 compatible or not. Based on that, once the certification is given, then they can sell equipment in the market. So in India, we have 35 states, and so department has given the task that every state we should have IPv6 nodal officer, and we have, the government has given that the activity sheet, how you will access your existing networks and what are the plans for future. So the nodal agency, the Department of Telecom, has received information from all states. 35 states has reported the nodal officers and activity sheet as well as. So central government organization and ministries also has given the activity sheet. So in India, in any department, government department, if anything is required regarding the IPv6, the nodal officer has been appointed and consultant has been assigned. If any problem is there, you contact those consultants and work can be done without any problem. So as per the ethnic lab report, you see that 50% the deployment is there. Still, we have to do a lot So who are the top contributor for IPv6 as per the current report? So everyone can see Reliance Jio has made us too proud that we are the #1. And other operators, telecom operators like Bharti, Vodafone, Idea, so everyone is following the Jio on the IPv6. Thank you very much.
Are there any questions? Any question or comment? Yes.
The Reliance deployment, is that single stack or is that a VoLTE deployment supporting V6?
Say again, please.
The Reliance deployment with 100 million customers, is that a single stack V6 deployment?
Yeah, they are LTE deployment.
Okay.
Yeah. Thank you.
Any other question? Okay, Ajay, thank you very much. Thank you. Let's move to the last speaker, last speech. The last speaker is Mr. Ting Wang from TWNIC. He's going to introduce the current status of IPv6 readiness measurement in Taiwan. Please.
Hello everyone, I'm Tim Gong from TWNIC. Today I will present you the Taiwan IPv6 readiness. The outline is below. First, I will show you the status of IPv6 development in Taiwan, including the government network and the academic network. And the second one, I will show you the Chunghwa Telecom IPv6 deployment, include the major IPv6 milestones and their IPv6 deployment roadmap and the testing service. And the third one is the status reports for outcome of the criteria of IPv6 readiness measurement. And the last is the conclusion. Okay. First, we can see this light graph. It shows the Taiwan IPv6 deployment in government agencies. The government service network, the AS number is 4782, and the IPv6 user availability has arrived at 3.84% on the February 12th. And this diagram is the Taiwan IPv6 deployment in academic network. The Taiwan academic network we call the TANET. The AS number is 1659, and the IPv6 user availability in TANET has arrived at 19.49% and is sustained growth. And the IPv6 traffic in TANET is go up. The traffic, this diagram shows the traffic of Taiwan in IPv6 of TANET is around 3.8 gigabit per second. And the IPv4 traffic is around 20.75%. So the IPv6 traffic is accounted for 80% of IPv4 traffic. And we can figure out the network traffic in the TANET is increased at the daytime and decreased at the night. After the government and the academic network status, let us see the ISP status. We choose the Chunghwa Telecom, the biggest telecom operators in Taiwan. I will show you some their IPv6 development, the milestones and the roadmap and their testing service, testing that. This picture is the major IPv6 milestones from Chunghwa Telecom. Chunghwa Telecom has participated in World IPv6 Day in 2011 and in the World IPv6 launch in 2012. Also in 2013, their IDC, the data center, support IPv6, and they support the government IPv6 GSM network project. And the roadmap of the fixed network and the mobile network, we can see the next slide. Okay, for the fixed network, FTTH, Chunghwa Telecom has do IPv6 trial service last year, and may expand the trial on this year. They plan to provide the commercial FTTH IPv6 service next year. For the mobile network, the 4G LTE, they have do the service, trial service for their staff and some customer in 2017. So they plan to provide the 4G LTE commercial IPv6 service this year. And the public wireless LAN in Chunghwa Telecom is like the FTTX. They do some trial service in these few years and plan to provide the commercial service next year. Hello? Okay. This is the IPv6 testing service in CHTTL. CHTTL means the Chunghwa Telecom Laboratories. It's an R&D lab under Chunghwa Telecom. It established in 2003. The IPv6 ready logo accredited lab in Taiwan. The IPv6 ready logo program is a conformance and interoperability testing program intended to increase the user confidence by demonstrating that IPv6 is available now and is ready to be used. And the CHTTL provide test capabilities include IPv6 core, IPsec, DHCP v6, SMP v2c, and the C router. So this picture shows some activity by CHTTL and some vendor whose product passed the test and got the ready logo. A total of 1,693 products worldwide through the IPv6 ready logo certification. Taiwan has the 320 products and accounted for about 80.9%. It's second ranked in the world. Okay, let's see the three common measurement criteria. The first one is the IPv6 BGP advertisement. The ratio of the IPv6 BGP advertisement in December last year has arrived at 40.77%. The second one is the IPv6 service availability. This data is collected from Alisa's top 1 million website, And the ratio of the IPv6 service availability in January this year has arrived at 50.39%. The third one is the IPv6 user availability. The ratio of the IPv6 user availability in February 2018 is around 0.85 on the February 24th. Okay, I'd like to end with a brief conclusion. The ratio of the three common measurement criteria, the IPv6 allocation and the BGP advertisement, service availability and the user availability, steadily grow up in Taiwan. And Chunghwa Telecom has done their trial service in 2017 and plan to provide the 4G LTE commercial IPv6 service this year. We hope the IPv6 ratio could be increased after the Chunghwa Telecom provide the IPv6 service. Thank you for your attention.
Are there any questions or comments? Any question? No? Okay, thank you. Thank you very much. Let's thank all the speakers, and I'd like to thank all for participating in this board meeting. This meeting is adjourned. Thank you very much. Thank you. I'd like to ask all the speakers come to the stage, and therefore we can have a group photo. I'd like to invite all the speakers, okay, come to the stage.